Welcome to Image Processing with ArcGIS Pro. 12 YouTube videos summarize image processing lab exercises available in a step-by-step lab manual that accompanies this textbook. Download the lab manuals at the site shown and obtain more textbook information at the second site shown publisher's website. Download the lab manual and data used in the lab exercises if you want to use the step-by-step instructions and process the imagery and DEMs while viewing the YouTube videos. The examples used in the videos and lab manual are discussed and shown in the textbook, improving GIS student understanding of essential remote sensing principles and technology while learning how to process and enhance images and DEMs using ArcGIS Pro. The lab manual, a page is shown in the upper right, and 12 YouTube videos are designed for GIS instructors, students, and users who want to do their own processing, enhancement, and information extraction of satellite and airborne images and DEMs using ArcGIS Pro. You can see the 12 exercises, the tutorials listed here. They cover a broad range of image processing tasks, algorithms, and help you find where these tasks are located on the various menus in ArcGIS Pro. The lab exercises require ArcGIS Spatial Analyst extension. Contact Ellis at ellis-geospatial.com for any questions or comments, and visit the publisher's website for more information and resources on the textbook. Lab 8 covers digital elevation models. The two examples are completely covered in the textbook. You can see the list of what we'll be doing. We're going to color code elevation, do a hillshade, and then contour with Space Shuttle digital elevation model. And then we're going to use Lidar to examine a DSM and a DTM. So here we're looking at our Lab 8 data folder, SRTM for Afghanistan. We're going to drag the DEM. We dragged it into our view, and we'll go to symbology. And it's already highlighted, and we just go min-max. And you can see clearly shows topographic relief in this mountainous area of Afghanistan. Now we'll color code the DEM. Got this drop-down menu, show the names, and you can pick any one you like. I'm partial to the rainbow. You can see our elevation range is from 1736 meters to 6051 meters. But what if we only want to look at the terrain above 4000 meters? How can we do that? We can touch this histogram and move the slider over to around 4,000. You have to move both of them to activate that histogram, so that now we're only looking at elevations above 4,000. You can also see that there's not many pixels that have elevations above 5,000, so we'll slide this over to 5,000. And it's certainly a more informative digital elevation model for the high elevation areas, which is what we're interested in this lab. And you can see our legend over here in the contents doesn't reflect reality. So we want to go back in our symbology tool and change the label. What's nice is you can make it longer than just a number. So actually what this is equal to or less than 4,000. And this one is equal to or greater than 5,000. Well, let's say that we don't like this dark blue background. We want to turn it just to a gray so the viewer really doesn't notice the areas we're not interested in. And there's different ways to do this, but one is we can go back to catalog, load the Space Shuttle DEM again, and in our symbology, go up here for classify. And instead of 5 classes, we just want 2. Now we have 2 classes. We can change this value to 4,000. and make it this gray, and make this no color. So now you can see we're just focusing the viewer on areas that we're interested in above 4,000 meters. And we can save these as layer files. So that's where that sharing, save as layer file, DEM output. We'll call this one SRTM 4 to 5K. It only works in Pro, but pretty handy to have these layers if you're going to keep coming back to this area and working this particular scene. And let's save our project. Now we'll uncheck these and we'll do a hillshade. We'll bring in the same data set the third time. And we'll do a min-max on it. You can do a hillshade in the imagery tab, these raster functions. You go down at the bottom, you see surface. And this makes a temporary image. We want to make a permanent GIS ready. So we'll go to the geoprocessing tool and say hillshade. And there's our hillshade tool. The input raster we'll pick the top, call it DEM hillshade, and we'll illuminate this from the northeast, so 045, and we'll have the sun, the illumination source, 25 degrees above the horizon. So now it's 045. For the azimuth, the altitude is 25, and we're ready to go. Beautiful. Now it's highlighted, and so go back to symbology, and I'll just do something like a standard deviation, brighten it up a bit. We want to make sure that it's a smooth image, so we'll do cubic so that we get some nice rendition when we're looking at it. I want to make this hillshade transparent and have some nice color ramp underneath it, so I'll turn it off. I'll highlight my DEM, go to symbology. I'll pick one of these nice elevation ones. Maybe that's richer tones. And if we put this back on top and make it a little transparent, see, now we have a beautiful image, very informative. And so the color scheme that you apply really does make a difference. But it's a really very good looking hillshade DEM with our color-coded elevation underneath. And we'll save the project again as we're moving along. So this hillshade has the sun coming from the northeast. We want to see what happens if we make a hillshade with the sun coming from the northwest. So we'll go back to our geoprocessing, and it remembered what we did before. The input raster was the geotiff, and we're going to make an output raster, but this is going to have the hillshade from 315. So now it's coming from the northwest, should work. And the same as before, we'll give it a stretch to brighten it up a bit. And turn this off, and we'll make this opaque. So we've got these two. If I highlight this and I say swipe, remember this one, the sun's coming from the northwest. You see this dramatic difference in what you see as far as fracture patterns or any linear pattern that you're working on the Earth's surface. So this is from the sun is from the northwest. Here the sun is from the northeast. So you can see which valleys are really accentuated, which fracture systems. Same data set, different azimuth direction of the solar illumination. So I'll zoom back out, and now we're going to contour. Should collapse some of these. I'll just leave one on. And in contour, let's go back to the geoprocessing menu. Hit that little arrow so we get to search contour. In our spatial analyst, you can see there's different selected range of contours. We're going to do the standard contour. We want to make sure we don't use the Hillshade. You have to use one of these real DEMs. The output feature class, and I'll call this shapefile SRTM 500 meter contour. We're going to make this 500 meters. It's quite a mountainous area. So you type in 500 for the contour interval, and we'll start at 2000. That's it. Should work. And there's our contour, all green. So we want to, once again, this is highlighted, go to symbology. Instead of a single symbol, go to unique values and make it on the contour. And it comes up with this random color scheme, which isn't very useful, actually. It would like the colors to be gradated from, say, blue to red as we go up. And so what you have to do is you have to click this Format Color Scheme, well hidden. And here you've got a choice. I'd like a continuous color scheme, and I'll just take their default. But this is saying low is red and green is high. But you can pick different colors. You have to highlight the one you want to work on. And so we could make this one, say, let's make it blue. And you click on that and say make it red. And you have different algorithms. And we'll just say okay. You can spend a lot of time on this, that's for sure. But now our elevation, it goes from dark to bright. If we don't like all its other values, because that's not really necessary, click it here. And then you get rid of that. You have a very clean legend. And you want to work, because this isn't very useful. It's so dark and everything. So let's just say we see what it looks like, this color combination on our color ramp, and maybe we'll try highlight this. It's highly interactive. So you get to tell the story that you want to tell, and it's really good. So let's save this project. If we wanted to share this very cool image that we just made, you go up to share, send it out as a JPEG. I'm in my output folder, just say map. And there's our representation, is a JPEG. Space Shuttle imagery in Afghanistan. So that concludes the work with the Space Shuttle using the Spatial Analyst extension. If you have the 3D Analyst extension, then you'd be able to continue on and do a topographic profile, which is very interesting. Oh, one thing I didn't bring over was sorry about that. I'll zoom back out. Zoom to layer. Go to catalog. In our data folder, we've also got a Landsat data. Ooh, it's hung up. It's doing something. You can see I can't open up my data folder. Glitches like this happen occasionally when you're working ArcGIS Pro a little too hard. Something goes on. So I'll probably have to stop and reload that folder, but we'll see. So what I had to do is go back up here. They're up to folders. Then add a folder connection back to the Lab 8 folder. So there was a workaround. Up here, this is the Landsat image. And if I put it underneath the contours, you can see the contours are a little too coarse. For what we're looking at, we do a unsupervised classification with this in another lab. These are cirque glaciers. And what you can do is say, turn this off, make the appearance of that a little transparent, and just have the black and white grayscale underneath. and you get a better handle on the topography underneath these cirque glaciers. The sun is coming from a different direction on a Landsat in the northern hemisphere at 10 o'clock in the morning. It's coming from the south, whereas our illumination for our DEM is coming from the other direction. So it may help you perceive these as cirques. These are basins. Seen clearly there because the shadow is cast down towards us, and on the Landsat the shadow is cast the other way, but this sort of supersedes that. So if you had 3D spatial analysts, you can do a cross-section across this Landsat using the DEM as the elevation for your topographic profile, and you draw a line and you profile, and across that line this is the topography. So it's a really good tool, but you need the 3D analysts. You can create perspective views like that and rotate them around and do a lot of good work with that. I have not been able to make an anaglyph in ArcGIS Pro. You can read this in the lab manual, whereas with the desktop I could. And so that's very informative when you make these anaglyphs of imagery draped over your own DEM. It's your vertical exaggeration, your exaggeration as far as the parallax. Sometimes you see things because you can rotate this, and so it's valuable if you have the 3D analyst to proceed with that part of the lab. And with that, we'll wrap up this DEM portion and move on to just looking at a DSM and a DTM collected with Lidar data. We'll save our project again. So here we are in the second part of this DEM lab. We're looking at Lidar data in California. We have a ortho photograph. It's just one tile out of hundreds and hundreds that were acquired. And it's been resampled from 1 meter to 2.5 meters for this lab because just the data gets too big. So I'll leave the topographic map on. It's pretty interesting. So you can see in the lab I ask, what are you looking at here? What are these different landforms? What are these? And what are those and that? So I won't give the answer in this YouTube video. And the digital surface model is the first return. So when the LiDAR is hit down to the earth and it returns, it's whatever's there. So it's the top of the bare earth if it's exposed, top of buildings, top of cars. We'll put that on top. It's 32 bits, so we go to min-max. And we'll give it a color scheme. So we go from 68 feet above sea level to 278 feet above sea level. This is the DSM. We should make it a hillshade. So we'll do that again. So we just say hillshade. With our spatial analyst tool. And this is the DSM hillshade. DSM. And it'll come from 315, 25 elevation. So 315, have it come in a lower elevation. We'll run it. Pretty spectacular. We'll make sure the appearance is, we want it bilinear, so it's just smoother. This is a whole county survey, so it's not the highest resolution that they're collecting on other surveys, but you can see this landform that we saw before. Well, let's highlight the hillshade and fade it. So we have some nice colors. Yeah, we'll go to 50%. Interesting. I don't like this color scheme because I'd sooner have the reds on top. So let me see if I can change that. So to change it, I go over to this format color scheme and these funny little triangles, reverse color scheme. I like that. So red is high and the blue is low. And so this is the digital surface model. These are actually solar panels above a parking lot. Now we'll compare this to the digital terrain model, which is where the analysts and also the software now strips off the trees, you strip off the buildings, and it's just the bare earth is what you're trying to see. So we go to symbology just like I did before, min-max, try to give it that same color. I'm sure if I save the color scheme somehow, I just haven't figured that out. There, red is high and blue is low. And now I want to do a hill shade of this. So I go back to geoprocessing, change this to the DTM, change my output raster. See, it's pretty efficient that it remembers what you did before. 31525 elevation. That should do it. It's going to be spectacular. I already know this. And I just highlight this, take it to 50%. You may want stronger colors, then you go up to less transparency. But that's the digital terrain model. And notice these steps. And so in order to merge these, I would take this image, I would zoom to layer. I would take this image and make my frames, this filled up the whole view, and then export it. I'd turn off these two. And so I would export this image, combine Hillshade plus the color ramp, and it'll make a new image. Then it's much easier to swipe. It's very hard to swipe right now. So if we go and put it on our air photo, you can see the type of terrain we're dealing with, our digital surface model, the type of terrain, these bumps. Now we know what they are. If there was a higher resolution LiDAR data set, these are incredibly crisp. You can tell that they're structures. And then the terrain underneath, pretty spectacular that they can eliminate the objects that are above the surface of the earth. It's a real skill set. The LiDAR has come so far. The ASPRS is, with the USGS, leading the way on the quality and the accuracy and formats so that you can interchange data easily. So we'll zoom to layer. And with that, we'll conclude the DEM Lab 8.